And today I'm going to give you an overview of a solution we come up with to calculate a consolidated forward weeks of cover view using source data from our planning system. So without delay, let's get this underway. So for those that may not know of Cotton On, we are a global fashion retailer based out of Geelong in Australia. Currently the business operates across 16 countries and 7 brands. And some of those brands you may be familiar with on the right-hand side of this slide. We currently have over 1,300 company-owned stores globally, along with operations in the online, license and wholesale markets. In the business, stock cover is a key planning metric that's extensively used. From the source planning system, however, this was only available at individual country and product category levels. And the business required a view of this across various different consolidations, particularly around country and product category, all the way up to a complete global group view across all countries, all brands, all categories, everything. In addressing this, the vendor of the source planning system was approached and estimated around 20 days to build a solution in the source system, which is a relational database system, which obviously brought the limitations associated with that around things like real-time processing, the requirements for batch processing to recalculate results, and the like. So given this, I suggested TM1 as an alternative to use the source data to come up with the consolidated calculations. And given the great working relationship that myself and Cotton On have had with Cubewise over quite a few years now, I got in contact with them and gave them a brief of what we're looking to do. And from this, Cubewise suggested we look at preparing a POC. And from this, PIOT was sent in for 2 days to complete this proof of concept. So now if we have a bit more closer look at stock cover in particular, simplistically stock cover for any given period looks at how many more periods can be covered with current levels of stock. So from a forward weeks to cover perspective, we're looking at how many weeks ahead can we go with our current closing stock level based on the forecasted sales for the weeks ahead. And in this simple little example here, you can see here that at the end of week 1, we're saying we have 100 units of stock on hand. So based on our sales in week 2 of 50 units and in week 3 of 60 units, that 100 units of stock is roughly going to get us close to nearly 2 weeks down the track. In this case, it calculates out to be 1.83, slightly in between, slightly towards the end of week 3 here. Similarly, as we move to week 2, where our stock on hand units has become 90, you can see that based on sales in week 3 of 60 and in week 4 of 30, those 2 weeks combined is exactly our 90. So that gives us a week of forward weeks of cover for week 2 of 2 weeks. And this trend we just follow week to week, recalculating for every week what is our forward weeks of cover based on our closing stock and our predicted sales moving forward. So where did we begin? To start with, I built an Excel prototype to replicate the calculation of the source system. Here, in this example, we're specifically looking at a combination of Australia and category 110, which is denim. And from the source system, our closing stock and sales were represented here in these 2 rows. So in week 1, we had a closing stock on hand of 1.14 million and sales for week 2, commencing week 2 at 70,000, then 74, and along we go. Also from the source system, given we're down at the individual country and category level, we also had their calculated weeks of cover, for week 1 being 15.52, So this gave us a point of reconciliation to understand how the source system was coming up with its calculation. So in replicating that, down here, you can see that the first thing we had to do was calculate a cumulative sales. So for week 1, our cumulative sales begins for week 2, given our stock on hand is the closing figure at the end of week 1. So for week 2, our cumulative sales just simply becomes the 70,000 for week 2. And then when we then add the sales of 74,000 from week 3, we will come to 145,000. And we just continue this along week by week, building up our cumulative sales ahead of week 1. And in the end, out here, you can see that somewhere between weeks 15 and 16 weeks ahead of week 1, our stock holding of 1.14 million gets depleted. So in 15 weeks ahead of time, our cumulative sales are slightly less than our stock. 16 weeks ahead of time, our cumulative sales are slightly more. So based on that, a simple calculation to find the exact intersection between 15 and 16 weeks ahead results in 15.52, which reconciles back to our source system. Similarly, we replicated this for week 2 and week 3, and again reconciled back to the source system's results of 13 and 12 weeks respectively. So using this prototype, the next consideration was how would we replicate this in TM1, and what were the challenges that we'd be faced with? So looking at the existing merch plans cube, which loads in the merchandise planning data each night from our source planning system, the major considerations were that this was a fairly large cube. It was one of our bigger cubes in our model. However, from a dimensions perspective, it doesn't have a great deal of dimensions. However, some of the dimensions have a large number of elements, N and C level. And the key dimensions that we were looking at to calculate our consolidated weeks of cover was country and category. And you can see there that country had over 75 elements and category over 1,000. Another consideration we had to consider was the need to cross over years. So the cube has separate year and week dimensions, and at some point towards the second half of each year, the stock will cross over into the next year before it is totally consumed. So in our solution, we had to bear that in mind, that we would need to do that crossover. So from all this, we had quite a few moving targets for the various involved intersections, and paramount to all this was to always consider the performance of the existing cube for the existing user base. So that was always at the forefront of the options we looked at. So what solutions were considered from a TM1 perspective? Firstly, we considered TI. However, given the cube size and likely high processing time, and also the ability to only operate at N level, this was quickly ruled out. The second consideration was to use rules with feeders. Again, given the large cube size and concerns around poor performance that would result from this, and also significant overfeeding required by two new measures in the dimensions of over 52 elements, this was also ruled out. Finally, we came up with the concept of using a feederless rule, or a number of feederless rules. Firstly, we needed to create two 52 element C level measures to represent the cumulative sales and the stock cover at the different intersections of the weeks. And then with all these C level measures, we would have a final C level element that sat on top of them all, and to rule them all to yield the final result. In taking this approach, feeding could be mimicked by using the stock on hand, because at the end of the day, if stock on hand is 0, then stock cover will always be 0. So we could mimic this using the stock on hand. So to have a look in more detail at the Feederless Rule, this diagrammically here shows how we structured the hierarchy of cumulative sales, weeks of cover, and the final result at the top here being our weeks of cover calculated. Firstly, we took our N-level source data from our planning system, our closing stock here, and our sales. And the first C-level element we had for every week, week plus 0, week plus 1, was our cumulative sales. And here you can see that for our week plus X cumulative sales elements, we placed the static closing stock on hand from the source system as the lowest level child. From this diagram here, you can see that by doing this and calculating the cumulative sales, the 1.14 million in stock again gets consumed somewhere between our 15 and 16 weeks here. And this result of 15.52 is returned at that point in time, being our weeks of cover, which we then take to the top of the hierarchy as our final result. So now let's have a look in a bit more detail at a demo, and let's revisit these three C-level rules here to look in a bit more detail as to what they are doing. So to move on for a demo, I'm now going to switch over to Arc here. And here we go. In this first view, you can see this is how we replicate or build the cumulative sales elements in the hierarchy. So here you can see at the top, the first 3 rows, again, is our source data coming from our planning system, our closing stock on hand, our sales, and the weeks of cover as calculated from the source system for this combination again of Australia and denim. So you can see here for week 1, the week plus 1 cumulative sales simply becomes our sales from week 2. And then our week plus 2 cumulative sales simply becomes the sum of the sales from weeks 2 to 3, and so forth as we come down this hierarchy incrementally, adding the sales to come up with our cumulative sales. Similarly for week 2, that hierarchy starts at week 3 here, and then based on sales from week 3 and beyond, it just builds up. So this is done for every week, and for every week plus X cumulative sales element all the way out for the 52 weeks. So let's have a look at the rule that's driving this cumulative sales. So I switch back to, this is the rule here, the C-level rule to calculate cumulative sales. So here, our week plus X cumulative sales is calculated as follows. The first thing we do is we look at, based on however many weeks ahead, is this going to cross over into the next year? As I mentioned, that was one of the considerations, that we would need to cross over into the next year. So here, this is how we do this. If the answer is yes, it does cross over into the next year, then what we do is we take a sum of the year-to-go sales remaining in the current year, and we add to that the year-to-date sales from the next year to come up with the cumulative sales. This is based on a number of year-to-go and year-to-date elements within an existing year-week period lookup cube that we have, where we structured new elements for every combination of week plus X to tell us what would be the year-to-go and the year-to-date. If the week plus number of X weeks does not cross over into the new year, then what we can do is simply take what is the remaining year-to-go sales up to our week plus X point in time. And given that we always calculate this based on sales starting from the next week, giving our weekly stock is our closing figure, we subtract from our year-to-go sales the current week's sales. So that is the C-level rule that we use to calculate cumulative sales. And that's the first of 3 rules that we use in this hierarchy. Returning back to ARC now, you can see here in this view that now, as we move down our similar weeks plus X weeks of cover elements, we have all zeros here until we get down to week plus X weeks of cover here, where we have our result. So this is based on the cumulative sales C-level elements now being a child of our weeks of cover C-level elements. And from this intersection, where we now know that our stock is consumed somewhere between weeks 15 and 16, we can apply our C-level rule for this weeks of cover. To do that, this is our second C-level rule to calculate weeks cover for future weeks. So basically says that weeks plus X weeks of cover, what it does is it looks at, is my closing stock in hand, is it greater than weeks plus X cumulative sales and less than weeks plus X plus 1 cumulative sales? So it's finding the point at which the stock is consumed. Now, if the answer to that's yes, then we perform this calculation to find the percentage of the week between the week plus X and week plus X plus 1 to return the weeks of cover. If it does not fall between these 2 weeks plus X and weeks plus X plus 1, then just return 0. So this is what results in all these elements above weeks plus 15 here being 0 until we achieve this condition where the stock does become consumed between this week plus 15 and week plus 16. If I return to ARC now, you can see here that what we end up with is here, we end up with this pattern here that's a bit like a moving target, like a graph. So as we go along weeks by weeks, the weeks of cover is getting calculated at various points between these weeks of cover C-level elements. And it moves along like so. And then at the very top, we have our final C-level rule here, which takes these calculated results lower down and brings them to the top. So to achieve that was our third and final C-level rule, where we used the consolidate children function. Now, use of this function was considered carefully. We monitored performance, and with this approach of this hierarchy without any feeders, performance was fine. We could have achieved the same result by putting in a summation of all these individual week plus cover elements, but in the end, it was safe to use consolidate children, so we simply did that to bring the result wherever it appears on the weeks plus cover hierarchy to the top. In the end, that gave us our result here. So from a reporting perspective, we could now just call this weeks of cover C calculated element for whatever week we wanted to return the result. Another really great feature here was that because this is rule driven, it's very dynamic. So what we could do is we can see in real time what the effects would be of changing the stock or changing the sales on the result. So here, as an example, if I was to add another $100,000 of stock at the end of week 1 and refresh here, you can see that my result has now become 16 weeks as I've got a little bit more stock based on the same sales to get me 16 weeks ahead rather than 15. Likewise, if I took 100,000 out, my weeks drops to 14. And if I go back to the original, I get back to my 15.52. Similarly, if I was to change the sales, say out here in week 6, if I was to add another $100,000 in sales and refresh, you can see that my number drops this time between weeks 1 and 6 because the stock is now going to be consumed more in week 6, so I'm not going to be able to get as many weeks ahead. If I take out the $100,000 of extra sales, you can see here that I return to my original numbers. I think this is a really cool feature and shows the power of TM1 and how the use of rules can make a real-time dynamic result. So that was the solution. So in the end, the final outcome, it was a great success. In the end, from the lowest level down here at Australia to all countries and everything in between, we went from the lowest level to the highest level. So our C-level rules worked. Here you can see that we have results for Africa for denim. We have results for all countries for denim. We have results for all categories Africa, all categories Australia, all the way up to all categories and all countries, from the lowest level to 18 weeks of cover for the entire group globally. Also, we put in rules in place to return this for different time elements, half one, Q1, total year, and that was simply return the last week in those elements. So great success. In the end, combining the resources of CubeWise and Cotton On, not only did we achieve the required results, but this was deployed to production by lunchtime on day 2 at the POC. We didn't even have to go beyond the POC to deliver this result. Completely fulfilled business expectations in minimal time with no impact on performance of the existing cube at all. In the end, a great money saver for Cotton On by not having to do this solution in the source system, and in the end, further prove the value of TM1 at Cotton On and was absolutely fantastic. So that's it for my presentation. If you have any questions at all, don't hesitate to reach out in the chat or send me a message directly. But for now, I'll hand back to Kemp.